Okay, we are having some technical difficulties. So we can't get my slides on. Let's just do
they hide it.
So just give us 2 minutes, please. Oh, wait, I don't know what that is. Okay, sorry for that. So I can't unify the display, so we're going to basically code like this because we're working off that screen. I'm Phillip. I work for Red Hat.
I'm Jan. I also work for Red Hat. We're both in the Quarkus development team.
Okay, so today we're going to start off with a quick overview, and then we're basically going to get into the demo, and we might pop back to the slides every now and then. We're going to take an existing REST application, and we're going to actually convert it to GraphQL and show you that you can already code GraphQL because it's very similar. During that conversion, it's going to include the server side. It's going to include more than one client as clients. We're going to talk about source fields. We're going to show multiple queries. We're going to show map support, mutation, subscription, security, error handling, and non-blocking. We probably won't get to all of this, especially now that we are a bit late, but we'll do our best. So quick overview for those of you who don't know what GraphQL is. It's a query language, first of all, for your APIs, but it's also a runtime to actually fulfill those requests that comes in. So it basically gives your consumers the power to ask for exactly what they want. A quick history, it's been developed by Facebook, but it's now open sourced and it now lives under the Linux Foundation. It's been positioned as an alternative to REST. It does declarative data fetching, and Facebook specifically done this when they saw an increase in mobile usage, and they had to start playing with smaller real estate, so size became important. And they had a variety of different front ends that all have different needs on what they request from the server. And it allows for rapid feature development, and it's been around for a while. The main thing that we're going to show is that we are solving the overfetching and underfetching problem in REST. Overfetching means that I'm asking, I have a service that will get a movie, and it brings back all the data of that movie, and I actually just want the title of the movie. And then to get the cast of that movie, I need to call another service in REST, and it brings back all the cast, and I actually just want 3 members of the cast. So overfetching is it returns too much data, and underfetching is I had to make subsequent calls to get all the data that I want. So the existing REST application that's going to be our starting point is a movie REST API. It's backed by a movie service. We're not going to get into the movie service, but just to tell you, the movie service gets its data from a database, the movie information itself, and then there's another service that returns cast members, so people that was involved in that movie, and that comes from IMDb as an example. It also has the model, so the model of what a movie is. A movie has multiple actors, the actor has a name, the actor played this character, and so on. And then we'll show the clients. So in the REST example, we typically have 2 types of clients, the JAX REST client, which is much more dynamic, and then the Typesafe micro-profile REST client. Right, so let's show that. So now we're going to see if we can code this way. So this is is this font big enough? Can you read? I'll go a bit bigger. So this is a typical REST API. I've got a movie resource under movie. I inject my backend service. Like I said, we're not going to get into exactly how we got the data or how we get the data. It's just some service that returns data. And then I can search for movies. So under search movies, I'll return a list of movie references. I can get a specific movie if I have the title. And then I can get the cast members for a movie if I have the movie ID. Right, so if you use Quarkus, you have Dev UI. So if you've been to the Quarkus talks up until now, you would have seen Dev UI, but I'll quickly show it anyway. Localized 8080 Q Dev. I must start my server, which typically would have been running if I wasn't battling with screens. Okay, so I'm starting up my application in dev mode, so you'll see that I won't restart any application as we build this going forward. Right. So in here, you've got all the things, all the extensions that's currently used in your app. We want to look at, not this one, we want to look at Swagger UI to show you the existing application. So as we said, we have search, so I can search for a movie. Let's try it out and search for The Godfather. Right, and I get a bunch of movie references back. I can also get a specific movie if I know the title. So the one that we're actually going to use is Top Gun Maverick, which I haven't seen yet. Right, and now I can get all the data around this movie back. It's quite a lot of data, though, so it gets me the company that was behind it, some awards and release dates, and a lot of data. And that's the overfetching problem, because I'm building a mobile site, so I'm only interested in the top actors and the name. Right. Now, this doesn't have the top actors in. It only has movie data in. So what I need to do is I need to go and get the ID and then go to another endpoint, which is cast, and then say, OK, now also get me this. And then I get the full cast that was involved in this movie. So this is the directors and the actors and the writers and all of them. I'll probably have to filter it down to the exact data that I want, merge it with the original movie data to actually get to displaying it on my screen. And that's the problem we're solving with GraphQL. OK, so let's get back into this. So what we're going to do is we're going to, this is our original design. What we're going to do is we're going to replace the movie and cast member with a movie GraphQL API. And then we'll replace the two clients with a dynamic client and a Typesafe client. And this is where I'll show you that you can already code GraphQL endpoints, because if you know REST, this is very, very similar.
OK, I will talk a little bit about the clients. As Phillip said, in the REST world, there are two types of clients, at least in the Java world. The microprofile REST client and the JAX-RS client, where the JAX-RS client is a bit more dynamic. And the microprofile REST client is kind of more type-safe because it works directly with your domain classes. And in GraphQL, at least with microprofile GraphQL, it is kind of similar. We have a type-safe and a dynamic client. So the dynamic client contains basically a domain-specific language that allows you to dynamically construct GraphQL queries that you can then send to the server. And back from the server, you receive data represented as JSON objects. With the Typesafe client, you code your classes that represent the data, and you request these objects. You get them back right as the objects. Both client types work for HTTP, work for all types of GraphQL operations. We have 3 types of GraphQL operations: queries, mutations, and subscriptions. Queries are the operations where you basically ask for data. Mutations are operations where you ask for data and then the operation can basically change something. So query is basically a read-only operation. Mutation is something that can not only return data, but also change some data. And subscriptions are operations that return multiple results. That means you can basically subscribe to multiple future events, and that works over WebSockets. Queries and mutations run over pure HTTP requests. You can also run that over WebSockets if you prefer. So let's go on.
OK, so let's get back to the code. So what we're going to do, I'm going to copy the existing REST endpoint and paste it in here. It's quite difficult to code like this. And then we'll zoom it a bit again. So to show how easy it is to convert the two, we'll basically just remove some annotations and change a little bit of code. So we'll start off by saying that, obviously, this is not REST anymore. This is now a GraphQL API. We're still going to inject the backend service because we get the data from the same place. A get is basically a query. We're getting data, so we'll say that this is a query. And we don't need to have a path parameter. We're not tightly coupled to HTTP like REST typically is. This is also a query, so we'll just say that this is a query. And again, we don't need this. And with this one, what we're going to do is we're not going to make it a query. We're going to say that if somebody asks for a movie, which comes from the database, we can add cast members. If they are interested in the cast members, we want to add cast members to movie, even though we fetch the cast members potentially from a different source. The way to do this is that you'll say that if the source field, so if the source field is a movie, then attach a new field onto movie called cast members. So now, and then make that queryable as well. So movie.id. And you can do this, and we'll go into this in a bit more detail, for anywhere down your object model. So any field in your object model, you can start attaching things to it. So this should be enough to get us going. So let's get back here, and let's go back to Dev UI. So very similar to Swagger UI, there's a UI for GraphQL called GraphQL that allows you to test out your GraphQL code. So let's start with getting a movie. You'll see that I have code inside here. It's because by default we generate a schema where with REST you have to attach OpenAPI or something similar to document your endpoints. This happens automatically in GraphQL. So the title of the movie will be Top Gun Maverick. Right. And then now I can start saying what am I interested in? So we're only interested, let's say, in the full title. And then, as I said, we might be interested in some cast members, which is now available due to that source field that I added. So I can say also get me the cast members. And it's queryable, so I can say I'm actually only interested in the actors, not the writers or the directors. And for the actor, I really just want the name and the character that they play. And then that's the data that it returns. So I'm already solving the over and under fetching problem because I can exactly ask what I want in one request. I think we can switch to the client now and first show how we do this in the client.
I can show how to do something similar with a client. Yes, to get a movie. So my application that I have here also is based on a REST client. This is a movie REST client. It's a command line application, so I will run it as a command line application in Quarkus dev mode, and I will, each time I execute it, I will pass as arguments what I want to do. So if I run this in dev mode, here, what was the operation that we wanted to do? Get, right? That was get movie. So I will pass that I want to do, for now, I want to just show that how my application does it with MP REST client. And I want to do operation named get. So I received basically the same that you saw with previously in the dev UI. I received all the over a REST client, over all the information about the movie Top Gun Maverick. Now I'll do this the same with types with a dynamic GraphQL client. So I have another class here that I will use where I will do basically the same, but I will do it with GraphQL clients. I will inject my GraphQL client here. This time I will inject an instance of the dynamic GraphQL client. I need to tell which one it is because I have multiple multiple GraphQL clients defined. Its name is movies. It's really odd to type to code like this. It's not on my screen. Okay, so this will inject a dynamic GraphQL client. I have it configured in application properties under this same key. I basically only this property is relevant to this dynamic client. The only property that I have to add is basically where the URL target is. So I have this property that says look into the contents of the URL. In our case, it's on localhost. Well, first we wanted to do this with two laptops actually, client and server separated, but then we said, yeah, that's way too dangerous for a live demo, so we're doing it on the same computer. But you can imagine it's two different computers because we're using two different IDEs. So this is how I configured my dynamic client. Now in the application, I can inject an instance of it like this, and I will now implement the get operation. So if somebody asks me hold on. Yes, this was with the dynamic. Sorry, this operation was for the Typesafe client. I'm completely messed up. So this is, I need to inject my Typesafe client. I will inject both because I will be injecting both anyway. So GraphQL client, movies, Typesafe. Okay, so the operation get. What we will do is Typesafe client, get movie. I will just hard code the title here to make it easier. So that was Top Gun Maverick. And let's have a quick look into the Typesafe client class, what it actually does, what it looks like. If we look at the query here, it's an interface. It's annotated with GraphQL client API. So it means it's a Typesafe client with this configuration key, just like with the dynamic client, it also had a configuration key. This one has a different configuration key to be able to configure where it connects to. But the most important thing is that I will be asking the server, I will be invoking a query. The query is named movie. That's derived from the method name. If I name it getMovie, it turns that into movie, right? It assumes that the operation name is movie. That query has one parameter named title, and it returns a movie. So I have a class named movie, which basically contains the same set of fields that correspond to the fields on the server side. So I can now call this, inject a Typesafe client, get a movie, and store that. Because it's a Typesafe client, I get a movie directly, and to kind of show what actually we receive back, I will serialize that into JSON, so you can see in the log what we actually receive. Now I will rerun the application, saying that I want to use GraphQL and do the operation named get. Perform the operation named get. And here you can see that I received the same, that I received a movie, Top Gun Maverick, with the ID, full title, year, whatever. Again, at this time I requested all the data because the movie class contains all the fields. But if I with GraphQL, I can receive just only the data that I want. So if I removed any of these fields, then these fields wouldn't be fetched, and basically, this server wouldn't have to send them back to me. This is how the Typesafe client works. If you want to receive less data, you just don't include these fields in your domain class. Okay, that's it for now for me.
Okay, so what we want to do next is we want to go deeper into the graph, and what we want to try is we said that all the cast members is too much. I'm only interested in the top 3, the stars of the show. So what you can do is add another source field. This time we're going to add it on cast members. So we're only interested in the actors, the main actors. So now I say that if there's a cast member, actually allow me to pass in the limit, and then we'll just filter out the rest. And that, as you can see, you can actually build a graph as deep as you need. In any of the models, you can add the source field to do exactly this. Right, so let's save and quickly show that. So now, rather than actors, if I just refresh the schema, I now should have a field on cast members called main actors, which I now need to pass in the limit. And let's say we only care about 3. Right, so now my response is much smaller, first of all, and exactly what I wanted.
Yeah, I can show this with the client.
Yep.
I will cheat a little bit to make it faster. Okay, so this time we're basically, again, invoking the same query. It's, again, the movie query, but we're requesting different data. So I have a different class ready for that. Yeah, this is the query that we will be invoking. This is, again, the same. operation in our case is main actors. It will invoke the same query, movie, but it will request basically only the cast members field. So how do we do that with the Typesafe client? Well, we have a class specifically for this, and this class I named movie cast members only because it's a class that represents the movie type, but it only contains one field, and the field is cast members. And in our case, and if the cast members is of type cast members with main actors, and that contains some fields that don't have to be here there, but also the main field that is what we're talking about here, and that the field is main actors, and that's a list of actors. So we have separate class with different sets of separate class with the different sets of fields. So it means we will fetch a different set of different kind of data. So as I said, I will cheat a little bit and just do this. And so what I do is, again, using the Typesafe client, I call the get main actors. Yeah, I should probably show also the declaration of that method. I called it get main actors. I had to set the query name because it actually calls the same query on the server. The query is again named movie. If I just left it without specifying the name of the query, it would deduce that the query is named main actors, which it is not. It's named movie. So I had to tell that the query is named movie. So it's the same, actually the same query as before, but I receive a different type. So I would request a different set of fields. The query has, again, this one parameter named title, but there's another parameter that was, in this case, added, and that's the limit, how many main actors I want. And that it's a nested parameter. If you look again at the query, you can see that the limit parameter is nested inside the cast members field and inside the main actors field. So how do we specify that? Well, using the nested parameter annotation you see here, cast members dot main actors. That means that this value passed to this method, to this argument limit, will actually be transformed into a value for this parameter inside the query. So I specify the title, Top Gun Maverick. The limit will be 3, and I'm interested in the main actors. So from the class, I get the cast members, and from the main actors. Now I can actually invoke it. I want to use GraphQL client, and the operation is named main actors. And you can see I received, Val Kilmer, Miles Teller, and of course Tom Cruise, the three main actors in the movie.
Okay, so that's basically source fields. What we want to show next is that we've added support for maps. Now, it might sound like something that just should be there, but in the GraphQL specification as hosted by the Linux Foundation, there's nothing like maps in GraphQL. And the reason for that is that a map is very difficult to traverse and build up a schema, because a map is just this dynamic thing that contains keys and values. So I can have a map that says my name is Phillip and my surname is Krüger, and I can't build a schema up of that because I don't know what's in that map to say that name is a field and surname is a field. So there's no such thing as a map in GraphQL. But because it's a popular construct in Java, we added support for it. And the way that we added support for it is we first added support for adapters. So you can build your own adapter and say that in Java, this is the class I want to, in GraphQL, adapt it to this class. We're not going to show adapters today, but just so that you know that this exists. And it's very similar to JSON-B adapters if you've ever used that. And then we've, on top of that, built some adapters that's included, like adapting a map. The way in which a map will be represented in GraphQL is a list of key value pairs. So, and if your reviewer, for instance, in our case, the reviewer is an enum, we actually have some insight on that field, which I'll also show. And then we've also added, by default, if you use maps, the ability to pass the key in, to query a specific key in a map. So let's see this. Did I save? So that's ratings. So we'll remove cast members just to keep it small. And then I have to refresh to get the new schema. So now I have a field called ratings. And at this point, it only has a key and a value, right, which doesn't mean much. And now we have an error. Let's just see. I have an extra. Thank you. It's quite hard to code like this. OK. Right, so now I get my map back. But as I said, you can also, by default, it'll be built in having the ability to query by key. And because this key is an enum, you can actually say that let's see what did we rate this. So we gave it 9.4. Right, are we showing this in the client?
I will show this in the client together.
Oh, when we do the mutation. OK.
Later.
Right, so next we want to move on to mutations. Up until now, we've only fetched data. A mutation, like we've said before, allows you to change data. So that means edit data, delete data, or add new movies, for instance. So it's very easy again. You annotate your method with @mutation. We're again going to return a map. And what we're going to allow you to do is to rate a movie. I'll show this a bit later. So for now, I'll delete this. So it's a very basic method that takes in the ID of the movie and the rating that you gave it. And then actually calls the backend service that does the work. Right. So to show that, so at the moment the rating is 9.4. We want to do a mutation, rate movie, and then now refresh this to get the latest schema. So now I can rate the movie and the ID I didn't get. Let me just quickly get the ID here. So this is the ID, so we want to rate this movie. I think this one will just be the one that we want. Oh, I could have just done this. Right, so let's rate the movie. We actually went and watched the movie, and then we thought it wasn't really good. Right, and we only care about Quarkus for now, so under return the results, we'll unreturn whatever we've rated it. So now I've changed the data. This could be a database call that actually changed the data in the database. Right, so let's show this client for this.
Oh, yes. Do I have that in the client? Hold on. Actors, mutation. Yeah, the operation rate. So again, I will cheat a little bit. This is again showing with the Typesafe client. There's nothing special here. I have the Typesafe client contains a method named rate. I marked it as a mutation so that the client knows that it's executing a mutation. It has two, in our case, 2 arguments. In Philip's case, it was 3, but the key is not required, so I left it out. and it will be assumed to be Quarkus, and it returns back a map of all currently known reviews of that movie. So I will basically call this method with specifying the ID, and I liked the movie slightly more than Phillip did. And I will, after I received a result, which is a map of all known reviews, I will just print it out. So let's execute this. I want to use GraphQL, client, and execute the rate operation. And here you see that's the result, that the rating from the Quarkus community has risen to 8.3 now.
All right. So we've done queries, we've done a basic mutation. The last main operation in GraphQL is called a subscription. So that's when you are interested in data and you want to subscribe to data. So what we'll do is we'll add a subscription that says that we are interested when the rating change. We use Mutiny to do this, and we use the multi-object to basically stream this for us. All right, so somewhere in my movie service, there's a broadcaster that broadcasts every time that somebody rates the movie, and then we want to stream it down to the client. Again, very simple. You just add the subscription and you return a multi. So to show this, what we want to do is we want to keep this open because we want to do the rating. But we'll open a new browser and then do the actual change of the rating. Right, so here we'll do the subscription. We'll say listen for a rate change. And there's no arguments, and now we can just say, okay, let's see what was the Quarkus rating. So as soon as I started, it's now opening a web connection and it's waiting for data. Right, so now if we, Jan convinced me and I said, okay, maybe 5.5 is a bit harsh, let's give it a bit higher. Right, so now we will receive the data there, and every time that I went and saw it, I liked it more and more, so it keeps on streaming the data.
Yeah, so I will show the same programmatically now. And this time I will use actually the dynamic client, not the Typesafe client. So this will be the code. This is what the dynamic client looks like. As I said, it's a DSL for building GraphQL queries. So here I built an instance of a document. Inside the GraphQL document, there's an operation. That operation is a subscription. The operation name is listen for rate changes, and here I say which field I'm interested in. So in this case, let's ask for the ID of the film, which there was rated, and for the Quarkus rating and for the Metacritic rating. So this way I built the document actually that describes what I want to ask the server, and then use the injected dynamic client instance to execute the subscription by calling the subscription method that returns a Mutiny multi. So I have to subscribe to it, and my subscriber, what it will do is basically just dump it into the printout. And I'm using a dynamic client, so I will be getting the data presented as a JSON object, not as any kind of Java class. So I will Optionally, you can convert that, of course, to domain objects. But in this case, I decided to just keep it as a plain JSON object. So each item that you receive is basically one response from the server after each event. And the data, the type of this data is, as you can see, Java XJSON JSON object. So I will just dump that JSON object into the log, just the raw data. Now I will execute it. Listen. And now,
I can quickly show that. I've got that script.
If you can open it in the browser in the GraphQL UI. Now, what it did now is that it initialized a WebSocket connection to the server, and for this particular subscription. And now it's waiting for events for new ratings. So when we actually perform some rating like this, give it 7.7. Now you can. You
need more space.
Yeah, and you see that there's already in the log. You see new ratings, Quarkus 7.7. If you do it again, it will keep that WebSocket connection open for as long as you need to receive notifications about new ratings for this particular movie.
Okay, we are running out of time because we had a late start, but let's do the next one. Yeah, so next I wanted to show reviews. Now, the reviews we're actually fetching from a different data source, and it's also non-blocking reviews, so I can return it as a uni. So we support non-blocking either by returning a uni or by annotating your method with @non-blocking, like everything else in Quarkus. And then we'll just return the reviews. So we add a new source field on movies, which will go and grab the reviews from another source, not our database, and add that to our source. So we now have, let's get a movie again. And now I should be able to get a review. What did I call it? I didn't save. Oh, and I miss a, nice, thank you. Okay, save. Right. And we'll just get the top review back for now. And let's just get the content back and maybe the title. So like I said, this typically comes from a total different source. That's why it's taking a bit longer as well. It's actually making a call out to the internet to some place where we do reviews. But now I have the review. So let's say that site where we get this data from is not available, right? So we'll simulate it by just throwing an exception and pretend that we've tried to get the data, but we couldn't. So if I do it now, I can still get back the data that I could find, which is the movie title, or any other field on the movie. But then the reviews I couldn't get, so I can get partial results back. So if you are aggregating data from different sources and some of them aren't available, we will still return as much as we can. So that's called partial results in GraphQL. So next I want to show how we do security. In GraphQL, it's as simple as basically adding, let's say only admin people can do. Actually, let's do it on the mutation. So only admin people can do the mutation. So we don't want everybody to be able to rate a movie. So we add roles allowed on admin, roles allowed on rate, and we say admin can do it. So this is standard. You know, it works the same for arrest and so on. What I also need to do is add a security provider, which is in my POM. And I'm going to add OpenID Connect. Because I'm using Quarkus, it will start up Keycloak in the background for me. If I don't have any configuration, it will start up Keycloak using dev services. Right, so if I go back here and I do a rate again, so let's rate the movie again, I should get an error. What did I do wrong? Rolls allowed, that looks right. Sorry, let me just see what happened here. Yeah, Quarkus restarted, which is fine because we've pulled in the Keycloak server. I'm not sure why this is happening. Let's just go.
Well, do you already need to log in?
Yeah, let's see if we can log in and actually get the data. I wanted to show the error, but so now I have, I should have a new extension called Keycloak somewhere, which is what dev services gave me. I can log in. I can say that I'm an admin, which is Alice and Alice. And now I'm logged in. And you can do all sorts of things like viewing the token and so on. What we're interested in is actually saying go to GraphQL, and be logged in. So now it works. And the reason for that is because we've actually set the request header. Right. Are we out of time? I think we are, right?
Pretty much, yes.
So we wanted to show quite a lot of things still, but I think we're out of time. So I think we should rather see if there's any questions and then take it.
Let's show the summary slide. I
Yeah,
guess.
we can show the summary slide and then.
And then open up to questions.
Yeah. Yeah, so we've shown source field. I didn't show multiple queries. Basically, multiple queries allows you to, if you say get movie, I can have another query that gets another movie that has less fields or more fields. So I can combine as many queries into one. We've shown map support, we've shown mutations, we've shown subscriptions and security. I've kind of shown error handling. We also support bean validation errors and normal exceptions and so on. And non-blocking we spoke about. We can also do transformations and mappings. So typically if you want to you have a double, but you want to map it to display it as a amount, so it has the dollar, and you format it a bit. You can do all of those type of things. Adapting, I spoke about, so that's how we've implemented map, but adapting from a Java object to what you want to represent in GraphQL. There's a context object, which I didn't show, but anywhere in your application, you can inject a context object, and this will give you context of the current request. So this is typically useful for downstream operations. So if you want to, for instance, know what this person has asked for and optimize your backend query. Batching allows you to batch to be more efficient, and we haven't shown that. Introspection allows you to use GraphQL to query GraphQL's schema. Directives allows you to define your own directive. We're starting to use directives internally to support federation and so on, and we'll start opening it up for users to build their own directives.
We can also generate, by the way, directives for bean validation constraints. If you have bean validation constraints on your domain classes, then they will get transformed into GraphQL directives. Yeah, integrations. Yeah, you can use to customize how the classes are transformed into JSON. You can use either JSON-B annotations or Jackson annotations. Both are supported. Security, we showed that. small right context, we talked about that. Bean validation also talked about that. Yeah, and you also get metrics. We support both microprofile metrics and micrometer. We also support open tracing. You can get tracing data from the invocations of your operations.
Yeah, we can quickly go through. We can maybe start taking questions. Are there any questions? There's a question in the back.
Is there a tool that helps you fetch data from the database more efficiently?
So like I've mentioned, the context, so you can build it on your own at the moment by looking at the context. We're also going to work on something like, for instance, Blaze persistence. We'll work on that to see if we can't let Blaze persistent look at your database and then create your GraphQL. But at the moment, nothing built in. No more questions? Sorry, I can't really see if there's hands. So I'll quickly just run through the roadmap. We want to add some more built-in directives, like, for instance, the ability to just say add pageable on top of your method. And if your method returns some sort of a collection, we will make it pageable automatically with some directive. Same for filter or limiting. So just basically doing the boilerplate stuff for you. Add support for federation. Allow you to build custom scalars. So a scalar is like the leaf node, like a primitive in Java, strings, integers, booleans, but allow you to build your own scalars. And that's it.
Okay, that's the summary. We showed how moving from REST to GraphQL is easy, especially with Quarkus on both the server and client side. GraphQL lets the client ask for exactly what they want, and the server will respond to it with exactly what the client wants. And anything else we have there? Yeah, out-of-the-box integrations, metrics, tracing, security, everything. That's it.
If you have any questions that you didn't ask now, please find us or reach out online to us and ask us. Thanks very much.
Thank you.